are related to about TCP header, and we have seen all the different flags and all the different fields of TCP that are related to it. Okay, so again, you already know that TCP works on transport layer. So TCP works on transport layer, and thus the here the packets will be referred to as segments. Okay, so most of the time whenever you are dealing the packets, that particular things will be referred to as segments. Okay, one more thing that I'll again do a formal announcement as well for this one is that uh, I'm increasing the marks for certification. Again, we are in the process. I'll tell you in the next week or so about the certification part. But now your certification will be about of 25 marks. And we have combined the assignment plus quiz. Okay. So if you are able to do the assignment marks are 10 and the quiz marks are 50. So if you are doing the certification, then 25 marks will be awarded to you. Okay, so you have to complete the certification part and more will be followed, because if you have attended what Mr. Tala Java, the session that I have told you about to attend in Saturday. If you have any doubt, most of the students may have asked their doubts on there, and I will be sharing you the link, because we are only in the final stage of finalizing the certificate, that is Network Defender, EC Council Network Defender course. Okay, so you have to do that, and after the completion of it you can easily be awarded 25 marks. There will be no quizzes that will be there in network security. Okay, so if you are able to do the certification, that is enough. Okay, so now moving on, any doubt till here? Okay, so moving on.
सर एक
Yes,
सर
yes.
जो हनी पॉट वाला असाइनमेंट था लैब का, सर उसमें
हम्म।
विंडोज में कौन सा हनी पॉट इंस्टॉल करना था विंडोज के लिए?
विंडोज के लिए आप कोई भी कर सकते हो, जरूरी नहीं जो मैंने किया, मैंने वहाला किया था।
ओके
आप KF सेंसर भी कर सकते हो, कोई भी कर सकते हो, बस आपने करके दिखाना, काफी होते हैं विंडोज में। ठीक है,
ओके सर
it is not necessary that what I have used you should use, but keep that in mind whenever you are using Valhalla. I think I have in one step told you to enable the telnet port. Okay, so keep that in mind whenever you are done with the experiment. Please close the telnet port on your Windows machine. Okay, so again, do not because it's again a vulnerability that you are creating, and just avoid these things. Okay, so KF sensor you can easily do that. KF sensor is also very easy to follow, but because if you are using the latest version of window, I don't think it will work. Okay, so it will provide a 14-day trial. Most of I have tried it myself on my machine, it was not working. Actually, I was not able to install that software. But if you are able to do that, it's again very easy to follow, very easy steps. You just have to enable and monitor. Very easy to do that. Okay, so if you are able to do that, that is also fine. I am not limiting you to
सर
only
सो
one window.
हाउ आर वी सपोज टू क्लोज द टेलनेट पोर्ट ऑन विंडोज? कि मैं वो भी
We
बता
just
दूं?
go on Windows feature on and off. Uh, Windows feature on and off.
ओके
Okay, so go there, search for telnet client and just untick it. Okay, now moving on forward with the TCP IP vulnerability part, that we have already seen a lot of things regarding the TCP part. We have seen that what is acknowledgement flag, what are sequential number, what is sequence numbers, and most probably this is the most important one, the sync flag. Okay, so these are the main things that we have to know about TCP, because whenever we are going to establish a three-way handshake, we will be using these three terms. Okay, so now what is the TCP vulnerability that is being existent in a Linux operating system? Okay, so there are three related flaws that are being found in Linux kernel handling of TCP network. Previously in 2015 and 16, the TCP IP flaws were very what you say severe. Okay, so the external the external network is able to get the remote access of your Linux operating system. It was that bad in 2015 and 16. But after that, we have there are a lot of right now there are patches exist for it, and that particular vulnerability is now being dealt with. But still, I think this is of 2019 or 2020. Okay, so this is of the session 2019 to 2020 that we have find again three related flaws. But again, this is being solved in Red Hat. Okay, so you are following any Windows version, there is a patch there. You can just install this patch to look that to see that if this particular vulnerability exists in your operating system. But most of the if you are using the latest version of Linux, any Linux, they are dealt with. Okay, so now you will not find this particular kind of a vulnerability. Now, what the vulnerability was, because to understand the vulnerability, you have to know specific terms that we have already seen. Okay, so the most severe vulnerability that could allow a remote attacker that still exists. Okay, so this is referred to as a kernel panic. Kernel panic is before going into kernel panic, you have to know these terms. That is acknowledgement, SAC, selective acknowledgement. So I'll tell you about it because I don't think I have told you about this. Selective acknowledgement. And then we have to know maximum segment size. I think I have told you about this one as well. And I think most of it is covered. Okay, so one more thing is SKB. This is the buffer size. I'll tell you about when I come to it. Okay, so still you are able to create a SAC panic. Just wait a second. Okay, so this issue has been assigned multiple CVE. So every time if there is any kind of vulnerability exist in Linux operating system, they will provide a particular number to it. So it is of 2019. So they're providing CVE 2019 11 4 77. It is important. It is considered as an important severity. So depending upon the number, it is referred to as an important part. And again, there is another part, whereas 11478 and 11479 are considered as moderate severity. Okay, so I will not be discussing about these because they are again very moderate, and it's very difficult uh, to exploit these two vulnerabilities. But you can exploit this one. Wow, wow, 11477. Okay, so that first two are related to the. Just wait a second. Okay, wait 1 second. I don't think my keys are acting weird. Okay, so now if you're seeing here, the first two related are selective acknowledgement. I don't think I have told you about this. It's very easy to understand. I'll give you an example to understand this one. Combined with maximum size segment, we already know that there is something called a buffer. Buffer is referred to as a window size. Okay, so what is a buffer and window is that the space that is available to your machine for communication. Okay, the space that is being available in your machine, and what is the maximum that you can send in one packet. Okay, so what is the maximum you can send in one packet is referred to as maximum segment size. Okay, so that we already did that. Okay, so selective acknowledgement is again very close to, if you understand the meaning of selective acknowledgement, is that they are not sending the acknowledgement of all packets. They are sending the acknowledgement of selected packets. Okay, so I'll tell you about why we needed this, because it's a very efficient scenario. It's very it is very what do you say, effective way to send acknowledgement rather than sending the acknowledgement again and again. It's a very good and a good what you say. I'll tell you why it is effective, why it is referred to as effective by giving you an example. Okay, so maximum segment size, we already know maximum segment size. Okay, so the issue detail are, there are three related flaws that we have already studied. That is handling of TCP selective packets, handling with low maximum segment size. The extent of the impact is understood to be limited to denial of service. Okay, so this was the thing, that if you are able to exploit this vulnerability, first you can first you can do a denial of service attack, DOS. Okay, Another thing that you can do is you can do a remote trigger. Okay, so these are two things. If you are collectively doing these two things, that is SAC with low MSS size. Okay, so it's very important. It means what it means is if you are doing a communication between two particular systems, you have a buffer. Don't worry, you have a window size. But if you have a low maximum segment size, and maximum segment size is dependent upon the negotiation between A and B. Okay, maximum segment size, because if you say that I can send you 10 bytes of data, but B can say I can only process, or I can only take like 5 bytes of data, then you are dependent upon this machine. The this particular B becomes the bottleneck of the maximum segment size. Okay, so maximum segment size is not totally dependent upon your machine to set. Okay, so it is totally dependent upon the machine in for which you are communicating with. So that is why it's saying that this particular vulnerability can be exploited when a low maximum segment size is combined with selective acknowledgement. Okay, so I'll tell you both of it, what it means. Okay. Now, no privilege escalation on information leak is currently suspected, actually that. And while mitigation show in this article are available, they might affect traffic from legitimate sources that require lower MSS value to transmit. Okay, so again, there is not much, what you say, there is not, because there are three vulnerabilities that we are talking about. So if you combine low MSS with SAC, there may be some kind of exploitation that you can do on the client machine. But again, if you see in this one, they are saying that it is moderate at this time. There is no escalation needed, and the information leak is very moderate. But I'll show you how can you get the a remote trigger if you combine three things. Okay, so first of all, now moving on forward, just a little bit of a background. That now you have to understand what is SAC. Okay, TCP Selective Acknowledgement. Now I'll give you an example rather than showing you this. I think I've given the SAC example ahead. So selective acknowledgement says that whenever you are sending a packet, so what happens? Suppose that this is your machine and this is your another machine, that is A and B. Okay, suppose you have sent, this is your buffer, and suppose it is divided into packets. Okay, you are giving a sequence number 1 2 3 4, something like that. Okay, so you are taking you are, rather than sending the whole buffer at once, you are sending a little bit, only one packet. Okay, so suppose I'm sending only one packet here. Okay, so one packet. After that I'm sending the second packet. After that I'm sending third packet. Okay, so if B have received all the packets, it will say that I'm expecting the fourth packet from you. So this is kind of acknowledgement, you already know that. Okay, so you're sending first packet, then second packet, then third packet, and B will say I have received the three packets and now I'm expecting from you your fourth packet. Okay, so now what happens if this happens? Suppose you're saying, now you're saying 4, you have not done 5, and then sixth packet is being received. Okay, so again, just wait, I'm saying seventh packet is also received, eighth packet is also received. Okay, so now if you're seeing here, the fifth packet is not received by the what do you say, receiver or the server, but sixth, seventh, eighth packet is again received by. So how can you say that I have not received the fifth packet? You will say that I am expecting fifth packet from you. Okay, so it will say I am expecting fifth packet from you. So A will think that I have sent 4, 5, 6, 7, 8th packet. So after fifth packet, the receiver is not able to get anything. Okay, so this was the limitation. So I cannot say that I only did not got the fifth packet. I have to say that I am expecting the next packet, that is fifth packet from you. Okay, so that was the problem. So when I reply fifth here, this user will understand that after fifth packet, after fourth packet, nothing is received by the receiver. So that is the main problem. If you're seeing here, this is the efficiency loss. Now what will this A do? It will again send the packet from 5, 6, 7, 8. Okay. So that was the main problem that was occurred whenever you're doing the acknowledgement for every packet. Okay. So there was no way to represent, there was no way to say that I have received this particular packet 78678, but I have not received only the fifth packet. Okay, so that is why we moved on forward with the selective acknowledgement. Okay, so we are sending the acknowledgement of selected packets, not the whole, only selected packets. Now what it will say is that there is something called SR protocol, so selective repeat protocol. Okay, so this particular selective acknowledgement is implemented in selective repeat protocol that you will study in your flow control. Okay, what is selective repeat protocol, what is go back N protocol, what are stop and wait protocol. These are three kinds of protocol you will study in flow control, and you will also be implementing in your labs. Okay, so don't worry about that part right now, just understand these are the terms that exist there. Okay, so now how do why exact is being important here? So see, you're sending a request and the communication starting from this side. Okay, so you're getting the segment 1, but your segment 2 is lost now. If you're saying here your segment 2 is lost now, the sending segment 3 with the acknowledgement 1. So you're saying that I have got the previous packet, that whatever you send, and you're sending the segment 4. Okay, so after a certain timeout, this particular machine will send, okay, I have received your it's saying acknowledgement, I have received. It is saying now this is a selective acknowledgement. It is saying I have received the sequence number 3 packet, and again said I have received the sequence number 3 and 4 packet. Okay, so it is selectively saying that I have received. Okay, I'm giving you acknowledgement that I have received third and fourth packet. So in this acknowledgement, if you're seeing here, there is no mention of 2. Okay, so if there is no mention of 2, this B will understand that second packet got lost on the way. So it is again sending this packet. uh, no, it is after some time, it is again sending this packet after receiving the acknowledgement. Okay, so it will again send a second packet to it, and it will reply whatever it is that I have this is acknowledgement. Now I have received, so it's a acknowledgement 1, and I have received the sack of 2. Okay, so with this B will understand that the packet is reached to the receiver. Okay, so this is more effective. Why it is more effective? Because you do not have to check every time, you do not have to send the whole window. Okay, so if in this time, whenever your packet was lost, you are sending the whole window again. Whatever you have sent, it is being received by this, but it cannot say that I have received. There is no way that it can say. There was no data structure has been set in this particular part. That is why it is not able to say. But if you're saying here, there is particular data structure that is being set, and they have enabled this thing so that sender and receiver can easily say that selectively we have received this particular packet, so that the sender will understand that which particular packet is not received by the receiver. So that is why.
Excuse me, sir.
Yes, please.
Sir, where is the SAC information stored in the TCP header?
Where is the
सर ये जो SAC information है, मतलब जब हमने TCP header पढ़ा था तो हमने कोई SAC header नहीं पढ़ा था, मतलब कोई भी जहाँ पे मतलब इसकी information store हो, तो कहाँ पे होती है?
So this SAC information is actually stored in option part. Okay, so there are 2 or 3 options there. You can enable these option parts. Okay, now moving on previously, that I'll just go with it. I'll just do the diagram. I'll put the diagram here. Okay, so I'll just shuffle it. Okay, so now we already know what is that SAC here. Now TCP selective acknowledgement is a mechanism where the data receiver can inform the sender of the segment that has successfully accepted. Okay, so this allows the sender to retransmit the segment of the stream that are missing its known good set. Okay, so that is why it's only sending the acknowledgement of those packets which is received by the sender. So that is why it is very important. Okay, so maximum segment size, we already know what is MSS. MSS is all again present in the option field of TCP header, and MSS says again there is something called packets. Okay, so whenever we are saying packets, and again we are dealing in network layer. We are saying packets or we are saying fragments. We are dealing in network layer. Whenever we say segments, we are dealing in transport layer. Okay, so just understand this terminology. Don't just confuse it with any other thing. Okay, so again, if you're seeing here, that is it's saying this, understand this one. The maximum segment size is a parameter set in TCP header of the packet that specifies the total number of data contained in a reconstructed TCP segment. Now, as packet might become fragmented when transmitted across different routes. Okay, so here in this particular statement you're seeing here, they're talking about everything from the first two lines in transport layer, but whenever they use a fragment term or the packet term, they have moved towards the uh, network layer. Okay, so that is why they are saying routing part also. So because routing is the responsibility of network layer. Okay, so everything you're seeing here is interrelated to each other. Again, when you understand the working of every layer, you will understand that actually what is written here. Okay, so still I think we have totally grasped the concept of transport layer, and network layer you will easily get this. So there are so many questions that are interrelated. So if you understand transport layer, it is very easy to understand the network part. Okay, so MSS we already know. So operating system that set the maximum segment size because it is dependent upon the negotiation that is going on between the sender and the receiver. Okay. So attackers with privileged access can create a raw packets with crafted MSS option in the packet to create this attack. Okay. So this is another thing I'll tell you about, that how can you do MSS attack. But again, this is being rectified now. You cannot you cannot set the MSS part of the sender or the receiver machine. It is totally dependent upon the operating system, because you should not be able to set the segment size. It is totally dependent upon the sender and the receiver. Okay, so if router says I cannot accept this much amount of information, so you have to decrease the size of your segment. Okay, similarly, this is TCP SAC. I think we have already seen it. So this is TCP SAC is very, very important whenever you are creating a, a, a three-way handshake. Okay, so here we are only saying, previously we are only saying acknowledgement. Now we are saying here SAC. Okay, so the process to permission to send and process selective acknowledgements, etc. This is establishment is process that is referred to as three-way handshake. This is a little bit of a diagram that is saying that the how the packets and segment flows from A to B. Okay, so moving on forward, I think this is the examples that are given to that is interrelated, that why we needed SAC. Okay, so if you see this example, it is saying that user A above sends 1 kilobyte of data where 3 segments of each 100 bytes. No need to go in detail. Just understand that it is saying that on the receiving end, B receive 1, 2, 4, 6, 8 to 13. Okay, so there is 3 packet is missing, 5 packet is also missing. Okay, 7 packet is also missing. Okay, so segment 3, 5 and 7 are lost but not received by the user B. Okay, so rather than if you directly say with the acknowledgement number, acknowledgement is the next sequence number you are expecting from the sender. So you will say that you will send 3. Okay, so the sender will not understand anything. It will say that this is expecting 3, so it means that it is not received anything after that. Okay, so it is same like by using acknowledgement numbers, user B will indicate that it is expecting segment 3. Okay, which the user A reads as none of the segment after 2. Okay, so none of the segment after 2 is being received by the user, because there is no particular data structure that existed if you use that technique to say that we have received this one. So that is why we moved on to the selective acknowledgement part, because this is not very efficient. And if you're seeing here, this is the TCP flag. Now it is saying that how to do SAC. Now you will say only 3, 5 and 7 is not yet received. So it will send those packets, only those packets, and it will again rearrange, because if you're seeing here, previously there is a lot of things that will be going on the sender side, receiver side. Okay. So if a particular packet is being lost, suppose 1, 2, 3, 4. So this one is being lost, second two. So it is received 1, 3, 4. Okay. So when you send that sack of 2, you say sack of 2. So I have not received that second packet. So 2 will be sent here again. So the format will be 1, 3, 4 and 2. Okay. So actually it should be 1, 2, 3, 4, but it is 1, 3, 4, 2. So that we do not want. Okay. So for this, you again have to give a little bit of a processing power here to reorder these packets. Okay. So that is why selective acknowledgement requires a little bit of a processing, but it is much more efficient rather than to just discard the received packet. And again, from this machine, it has to again send a lot of packets after that. So that is why it is a lot of it saves a lot of time as well as a processing power of the machine. Okay. So now we come to the SAC panic. So how can you create a panic? How the panic was created in 2019? Okay. So for it, there is something called socket buffers. This socket buffer can store, again it can store 14 fragment, okay, up to 17 fragments. Okay, so previously it was Linux socket buffer. Again, it's a socket buffer. It is used to create a connection between the sender and the receiver. So it was only able to hold 17 fragments. Okay, so if you're seeing here, it is a low buffer size that is being available at the Linux machine. Okay, if you're using Linux machine. So socket buffer, again, it's a data structure. Keep that in mind. It's a data structure that is used in TCP/IP implementation. It's a linked list of buffers. Okay, so it means that they have buffer. They are tied like this. These buffer will be 17. These buffer can hold only 17 fragments. Okay. So there are some of the things that it is a list. There will be something called a transmission queue, receive queue, that whatever you want to send and whatever you are receiving. Then there will be a SAC queue. Okay, in this fragment. Okay, so in this socket buffer, these are the things that we are doing. Okay, there are some retransmissions also. Okay, so it can happen that you are sending some data to B. Suppose 2 is sent to B, it is not received by it. So after a certain amount of time, you will again send this data. So that is referred to as retransmission queue. Okay. So it can hold packets of data into fragments, and it can only hold 17 fragments. Okay. So that is the main thing that you need to understand, that socket buffers that are present in Linux can only store 17 fragments. Okay. So with it, if you're seeing here, with each fragment holding up to 32 KB on x86. Okay, so this was a specification that is being set on the vulnerability part here, that you can only get on 32-bit machine of Linux. You can only hold up to 32 KB and 64 KB on 64-bit. Okay, so when the packet is to be sent, it is placed on the send queue, and its details are kept on the control buffer structure. It's very common, but you see here, this is what actually it is stored in the buffer. Okay, you see here, this is the structure part where two things are stored here, that is TCP GSO segs and TCP GSO size. Okay, so this is the structure part that they are talking about, that you can store this information here, and here you can store sequence number, finish flag, sync flag, data length, other things. Okay, but this is the structure part that is much important. So what is stored in GSO segs and GSO size here? Okay, so the GSO seg and GSO size are used to tell the device driver about the segmentation overflow. Okay, so it will tell you that if you want to offload any kind of a segment, the information that will be present here. Okay, in these parts. Okay, so now moving on forward, how can you create a panic? Okay, so this is how can you create a panic. When, now understand this part, when you are able to occupy all the 17 fragment space. Okay, so if you are able to get that if you are able to, because we already know that what is this one? Pocket buffer. Okay, so we already know that this skb can hold 17 fragment space. Okay, so if this particular 17 fragment space is full, okay, so it was rarely full, but there are some exceptions in which this particular space can be fully occupied. Okay, so when it is fully occupied, then there will be something called a buffer overflow. Okay, so buffer overflow. So when this buffer overflow occur, you have to call the function called bug on. Okay, in this one. Okay, so see here, when segmentation offload is on and SAC mechanism is also enabled due to packet loss. Okay, so their packet loss can easily happen. So if you're doing a packet loss, you have to put some packet into the retransmission part. Okay, so that is again a part of this fragment space. If there are a lot of packet loss, you have to again retransmit the packet and you have to hold those packet again, and the selective retransmission of some of the packets, skb could end up holding more multiple packets. Okay, so it is was, if there is a lot of packet loss, this particular scenario can happen, and it is counted by something called tcp geosegs. Okay, so multiple such skbs in the list are merged together. So when they are merged together into one, so to for it to become effectively process different sag blocks. Okay, so there may be, because this is a linked list, so they are combined together into one, so that they can see that what are the selective acknowledgement blocks that are being there, so that we can merge and we can process this together effectively. Okay, so it involves moving data from one skb to another in the list. We are just collecting skb uh, list data together. Okay, so again, when you are collecting the list data together, you will, what you do during the movement of that skb structure can reach its maximum limit of 17 fragments. Okay, so then gso segs parameter can overflow and hit what we called a bug on, that what I have told you. Okay, so this is the scenario in which this can happen. Okay, so when you call the bug on, now this calls the kernel to panic. Okay, so this call the kernel panic. Okay, so below resulting in the said kernel panic issue. Okay, so these are the situation in which can happen. Now you understand the situation, you can do this kind of thing remotely also. Okay, so when this kernel panic issue happens, now what you can do is this this is again whatever I have told you upon this is whatever it is written here, it is given in the buffer form. Okay, so this is how it is implemented in the coding part. Now understand that the how can a remote, okay, so a remote user can trigger this issue by setting the MSS. Okay, so that is what I'm telling you, because you cannot dependent upon MSS, you are dependent upon the other, because there will be a negotiation between A and B, because if A says I can send 20 bytes of data, but B says I can only accept 10 bytes of data, then you have to decrease the size of your maximum segment size. So you're decreasing the maximum segment size, or you can increase the maximum segment size from A or B. So that can happen. So bottleneck of both of this will become the segment size. Now, a remote user can trigger this issue by setting the maximum segment size of a TCP connection to its lowest limit of 48 bytes and sending a sequence of specially crafted this SAC. Okay, so I'll tell you about these. What are these? So you can, when you are setting the MSS limit to the lowest, and then you are sending specially crafted SAC packet, then what you are actually doing, your low MSS is being combined with your SAC packets. Okay, so this was a thing that is needed to create this panic. Okay, so if you are able to do this, this can lead to this. You can get a remote access, or you can trigger a lot of. You can exploit this particular thing to get a access of the machine. Okay, so MSS leaves merely 88 bytes of data per segment, thus increasing the number of TCP segments required to send all data. Okay, so now if you're seeing here, this is again what I'm saying is that you you will be able to get a lot of information. There will be a lot of things that you have to do. First, you have to set the MSS. Okay. So if you're able to set the MSS correct, so that it is being with SAC packets, and this specially crafted SAC packets are set in such a way that you're saying after receiving the data, you are again saying, please send me. Please send me the data. Please send me this data. I have not received. Okay. So you are, when you are sending this SAC packet, you are saying again and again, I have not received third packet, fourth packet, fifth packet, sixth packet. Now, what is this? By doing this, what you are doing, you are calling this source machine to retransmit the data. Okay. So when you have to retransmit the data, what will happen there? This retransmission will again take a space in the SAC buffer. Okay. So this retransmission will again take place in the SAC buffer, and you already know that that will again take a lot of space, and that will again in turn will say that the whole space is being occupied of 14 fragments, and then it will say to activate the bug on, and when the bug on is activated, there is a kernel panic. Okay. So in this particular kernel panic, there is not much you can do, but you can exploit this particular thing further. Okay. So this is just the steps that is telling you to reach towards this part. Now after that, I will not I will not tell you that what can you do. Okay. So you can go ahead and search that when there is a kernel panic, or how many things that you can do, how can you exploit when there, if you are able to create a kernel panic on the receiver machine. Okay. So this particular vulnerability being exist in all suites of Linux, all suites. Okay. So from Red Hat 8 to 12, all are being affected by this. Okay. So there was a lot of in 2019, there was a lot of attacks that is being involved because Linux is being used on the servers. Okay. So if you have checked the part, if you checked any kind of server there, just you will always find that Linux is being used on the servers. Okay. So they are using these particular kernel panic to attack those server, and this servers are mostly being you cannot, you can only do a denial of service attack. Okay. So those servers will become inactive. Suppose you are if you are able to do this attack on Google server, so you will not be able to, anyone will not be able to access the Google website. Okay. So again, this is being resolved right now. If you check here, this, if you type this particular thing, CWE 2019 477, you can find that this particular uh, vulnerability is resolved right now. And again, they will say that if you want to still check, you can download a patch, install it on Linux, and then it will tell you that this particular vulnerability does not exist in your system. Okay. So if you have a earlier Linux system, it may be possible that this particular vulnerability exists on there. Okay. So that is why it's always said that whenever you are using any operating system, always do the update part. Okay. So why update is necessary in every operating system? Because there are a lot of vulnerabilities that is being finded by, that is being found during these particular things, that the engineers find a particular vulnerability, that using this vulnerability these particular uh, third party people are trying to get access in the system. Okay. So in the updates, the engineers resolve this kind of things. Okay. So if you are using a outdating operating system or previous operating system, there is a very high chance that you can easily be targeted. Okay. So that is why whenever you use on mobile, okay, so I'm not talking about only Linux or on Windows, I'm also talking about your mobile phone operating system as well. If you see Android, most of the time, if you are not getting any security update, okay, security update is one of the best feature that you will find in any Android device. If you're not able to get security updates after 3 years or 4 years, your particular device will become vulnerable. Okay. So it becomes vulnerable to the attacks that is being not possible previously, because those security updates are very necessary. If nowadays it becomes so much necessary. Okay. After COVID, there are a lot of attacks on mobile operating system as well, not only on not only on Windows, because Windows was previously one of the most attacked operating system because of the usability that 98% of the people use Windows. But now it is being said that now people are moving towards Android operating system, because again many people, like majority of the people that exist on earth, are using Android for their daily day-to-day tasks. Okay, so now with this, now I'll tell you a little bit of a security measures that you can do in order to avoid uh, any kind of a security issue. Okay, so I think it was in the previous one, I have not uploaded. So there are some security policies that exist. So most of the policies that I'm being talking about here, you already know about those policies, but there are some policies that you may not know about. Okay, so there are something called account management policy. This is again for industries. Okay, industries or firm. These policies can also be implemented if you are on personal level also. Okay, so account management policy, you already know that which particular what you say access. Okay, so the manager will be able to see this much thing. So it is like privilege. Okay, so you're giving the privilege on a particular level, that this particular level will be able to see this much amount of things. So that is being implemented. Another thing is clean disk policy. Okay, so this is the purpose and principle of clean desk policy is to ensure that confidential data is not exposed to the individual who pass through the area, such as this one. Okay, so it's again, you are not keeping the files up that is being secure. You are not keeping those files without any kind of encryption. So that can and comes under your clean desk policy. And whenever you are sending this, you are not sending those files uh, not on company servers. Okay, so if you're seeing here, these companies what you say, spend a lot of money for ensuring their private servers. Okay, so for securing your private servers. Okay, so if you are working in a company, they will always say to use their internet connection. Okay, because their internet connection is being secured, and they have spent a lot of money towards this internet, so that there will not be any attack that can happen on company server. Okay, so but now this COVID-19 has changed all that, because wherever you are working in an office from home, this kind of security cannot be provided in a home network. Okay, so keep that in mind. Now they are doing some kind of a solution that how can we implement these kind of a thing at home, that how can people sitting at home can connect to company server that we have already worked on. But again, these are some things that you can think about. Okay, email policy is very easy to that. You can send any kind of you can establish some rules. So said you cannot send bulk send. Suppose if you want to right now, if you are in Bennett, you want to send email ID to all BU fraternity, you cannot send that. Okay, because you do not have the privilege to send that. Okay, so these are again limited. This will again come under account management policy, but still this is again an email policy that you should be aware about. Another thing is secure incident management policy, that if you see any kind of incident, any email that is being received, like if you see any kind of a suspected email, you can directly report to the IT. Okay, so this is comes under incident management policy. You should directly report to your IT that is working in your company. They will work there to ensure that it will never happen. Another is log management policy, that you always have to keep a log. And then there are some network security and VPN acceptable use policies. Okay, so because we already know that many people use VPN on the company's server to hide their IP addresses, what they are doing and what they are using. So again, that will again depend upon the company, that what can be done and what you should not do. Another thing is password policy. You change your password after certain. The password should be strong, personal device acceptable. Bring your own device. That is again another policy, that whenever you're bringing your own device, that is not that is not owned by the company, how much things that you can do on that device also. Okay, again another is patch management policy that will be again dependent upon the company, because if you're seeing here in Bennett also, if you're using their work laptop, their Windows operating system that is being purchased from Microsoft, they will have a different security standard based on the firm. So the IT people that is being working on there can do a little bit of patches, and they can define a little bit of guidelines that what can be done on the particular machine. Okay, suppose I got a laptop from Bennett and try to install a third party or any cracked software. Okay, so the IT people will always came to know that this particular person is trying to install a cracked software that is against the policy of the corporate. Okay, so these policies can be set. Another is server security policy, system monitoring and auditing policy, vulnerability assessment, telecommunicating workstation configuration policy. Okay, so you can read about it. There is nothing much to it. And in the next one, we will study about another Linux flaw, that is grub security flaw. Okay, so that is related to boot sector. Okay, any doubt till here? Okay. So thank you for listening. You can move on to the next one. Any doubt?